Hey, what's up? So I've done the electric skateboard, I've done the electric scooter. I thought it was about time to do the electric bike and complete the trifecta. So I bought a secondhand electric bike that wasn't working, and my goal was to get it working. Because this was my first time repairing a bike, I really didn't know what I was doing, so I kind of just bought the bike and decided to figure it out from there. So here was my starting point. I got the bike. The battery could hold charge, but nothing else appeared to be working electrically. I cleaned the bike and took it apart just enough to take a look at the controller. Now, the first thing I noticed with the controller was that it was just a typical electric bike slash scooter brushless motor controller. So I tried to find the same one online based on the codes and specs on the casing, but I couldn't find anything, which meant I had no schematic diagram and no clues on getting a replacement part. At this point, I decided to look at the other components to try and get a better idea of the system. Unfortunately, I didn't have the equipment to test all the components, but I was able to test the throttle, which I confirmed was still working. So purely based on the process of elimination, the problem was either the controller, the wheel, the control panel, or a combination of the three. Now, I could have bought replacement components individually, but I know that some parts from different brands and models don't always work together. So to save myself some trouble, I just decided to go with buying a whole new conversion kit. So to pick out the conversion kit, I had some specs to work with. And since most of these kits are pretty generic, I was able to find the one that matched my requirements. And if it's to help you, sometimes the seller will provide charts and tables to help you find what you need. Basically, I knew I needed 20-inch wheels, I needed a controller that would work with my 36-volt battery, and with an 11 amp hour capacity, I knew I was looking for a controller around the 350 watt range. After this, there were a couple other things I needed to match up. I needed to make sure the width for the rear wheel hub would fit within the rear drop spacing, and in my case it was 13.5 centimeters. I had to make sure the rear wheel axle length was long enough that I could secure it onto the bike. I had to make sure the width of the wheel was wide enough to fit the tire, which in my case was 1.75 inches. Now, something to be wary of, I bought a rear wheel that could accept a tire width between 1.75 inches and 2.25 inches, and innocently I thought, yeah, that works. Unfortunately, when I got the wheel, I noticed the wheel was actually a bit thicker than the original wheel, and this meant the wheel was skewed towards the left side and made the wheel graze against the mud guard. There also wasn't enough space for the brake on the left side, so really it actually wasn't a good fit. Fortunately, after doing some testing, I found the original wheel was actually still working, so I was able to continue using that. The other key thing I had to make sure was that the dimensions of the controller would fit within the designated area of the bike frame. As for all the other parts in the conversion kit, I basically assumed they would all fit, and fair enough, they did. Now, with the ordered parts on their way, I decided to look at other parts of the bike, and I started with the rear hub motor wheel. And up until this point, I was able to disassemble the bike with common tools like Phillips screwdrivers, Allen keys, etc. But to get the Shimano cassette sprocket off, I needed a Shimano cassette removal tool and a chain whip wrench. To use these, you basically wrap the gear with the wrench, put the removal tool into its slot, and rotate the tool left while using the chain wrench to keep the gears in place. This should loosen the cassette, which you'll realize because you'll be able to move the cassette more freely. Once you get it to this point, you simply continue to rotate the cassette removal tool counterclockwise without the chain whip until the cassette is off. And to add the cassette back on, this requires no tool, simply rotate the cassette clockwise on its thread until it locks. Note that you'll need a tool with an inner diameter that fits the hub motor wire, as not all tools have a diameter wide enough to do this. Now, while many of the newer bikes have accessibility to the motor, the hub motor wheel that I had was clenched shut, so there was really no designed way to look at the inside of the motor. Continuing to disassemble the bike, the other special tool I needed was to remove the crank. And after doing a bit of research, it turns out there's a few different crank types out there, but the one I was dealing with was a square taper crank, and this requires its dedicated crank extractor. Now, the way this tool works is by screwing the tool onto the crank threads where the bolt was removed, then using the inner screw within the tool to screw into the smaller threaded area to push the fastened piece away from the bike frame, forcing the crank to pop off. Now to put the crank back on, place the crank on its square axle, then with the initial bolt, rotate it clockwise such that it fastens the piece towards the bike frame, forcing the crank to be tightly fastened to the axle. In addition, another tool that was part of the process was the bottom crank bracket removal tool, which is needed to remove the axle. Note that a good idea for the bottom crank bracket removal is to do the right wheel first, which requires a turn clockwise, and then to do the left wheel, which requires a turn counterclockwise. Also note that I needed to do this to replace the pedal assist sensor, otherwise known as PAS. In terms of taking off the handlebars, this was a little tricky for me, but basically I grabbed a flathead screwdriver and wedged it between the grips and the handlebars. Then I dropped a little water in between and twisted and pulled the grips until they fell off. And when adding the new grips, I also lined the insides with a splash of water before attaching them. When taking the tires off the wheel, you could do this with a few flathead screwdrivers, but I found that using bike levers was super helpful, and 3 of them seemed to be enough for a 20-inch tire. When installing the brake handles, basically you extend the brake cable to pull it out and then reattach the cable to your new brake handles. Now that's most of my notes on the areas I found peculiar in terms of the physical assembly of the bike, and as for the electrical assembly, it was quite straightforward, except the wires that went through the frame of the bike involving one of the bike folds. Now this particular bike fold had a spring where the wires had to go through, so there was a certain cross-sectional area available to get the wires in and out. And pulling out the wires wasn't that difficult, but putting them through was a different story. So the way I went about this was I basically poked a bendable but firm wire through the bike frame to guide the electrical wires on where to go. I then wrapped the electrical wires around the wire guide and taped them up to reduce protrusions and to prevent the connections from getting stuck in the pipeline. Once I did this, I pulled the wire and with a bit of luck managed to get the electrical wires from the entrance through the spring and to the exit, and the rest of the electrical connections were fairly straightforward. When assembling the bike, there were also a few adjustments I had to make along the way. So after taking the chain off and playing around with the gears, I found myself needing to re-index them, which basically means to line up the gears correctly with the derailleur so that the chain shifts to the correct gear. Now there's a few things involved with this. The first is using the H and L screws. So on the derailleur there's a screw with a capital H above it and another screw with a capital L above it. Tightening the H screw, i.e. clockwise, presses the chain inwards from the right, and loosening the H screw, i.e. counterclockwise, allows more space for the limit on the right. Note that there is a set amount that this works for, so if you loosen the H screw or tighten it too much, it will eventually have no effect. So adjustments need to stay within the workable range. Tightening the L screw, i.e. clockwise, presses the chain inwards from the left, and loosening the L screw, i.e. counterclockwise, allows more space for the limit on the left. Note again that there is a set amount this works for, so if you loosen the L screw or tighten it too much, it will eventually have no effect, so adjustments need to stay within the workable range. The second way to help re-index the gears is with the barrel adjuster. So turning the barrel adjuster counterclockwise tightens the gear wire tension, which pushes the derailleur inwards, and turning the barrel adjuster clockwise loosens the gear wire tension, which pulls the derailleur outwards. Much like the H and L screws, the turning with the barrel adjuster only works a set amount, so once you loosen or tighten the barrel adjuster enough, it has no further effect, so it needs to be adjusted within the usable range. And if those two options aren't enough to get the rear derailleur in line with the biggest gear, i.e. gear 1, the third method is to adjust the derailleur tension wire. To do this, you need to loosen the derailleur's tension wire from its fastened position, press the derailleur manually to line it up with gear 1, then pull the tension wire so it's tense, and then tighten the screw again to hold the tension wire in place. If you find this step difficult, I found that moving the gear down to the smallest gear, gear 6 in my case, helped when adjusting the tension wire. Something to note about re-indexing the gears, and this might have just been me being silly, but I was originally indexing the gears with the bike on its side, and I ended up getting all the gears indexed except the chain by the front gear would fall off when backpedaling on gears 1 and 2. I could see that it was happening because the gears were slightly misaligned with the chain, but I couldn't figure out why. I ended up testing it with the bike upright and the issue went away, which makes sense as gravity would have been pushing the chain downwards. But after doing this, I then found that while on gear 1, backpedaling would cause the chain to fall off on the rear gear. And that turned out to be because the bike wheel was slightly misaligned, and making the rear wheel axis both perpendicular to the bike frame solved the issue of the chain falling off. Also, just a couple additional notes. An extra tool that I got but didn't end up using was a spokes tightener, which can be used to help align the center of the wheel. And also a good tip is to take photos or write notes to be able to trace your steps back, because sometimes you may do something and forget how it was done originally. And that's pretty much it for getting the electric bike working. Everything else to me seemed pretty typical of a DIY project. So overall, a very cool project. I learned a lot about bikes and it was just awesome to be able to complete the trifecta. Now I did also go a step further and set up a light system for the bike wheels, which you can check out in my other video. But otherwise, thanks for watching and hopefully this video was a little bit helpful.